very little to do with each other, as you're going to see. We just talked a little bit about the fact that your capillaries are pretty leaky, and so plasma is going to leak out, but most of that will be collected back up and return to the circulatory system via the lymphatic system. One of its job is to return plasma back to the bloodstream. The other one has everything to do with the immune system. The lymphatic tissue has lots and lots of lymphocytes. There's that prefix, lymph. So, again, transporting fluids back into the bloodstream and our immune response. We have different types of lymphatic organs, tissues, and whatnot, and we're going to go through all of those. But this is pretty straightforward. And there's not, you get a little bit of reprieve on the anatomy lab. There's only a couple of things I can actually get. We have one stupid model, not even a very good model. So you're going to get a break from that. But you will have to be able to recognize a lymph node under the microscope. So there's those rare times when you are responsible for the histology. Right. So again, you will have to know the flow. It's very simple. You have capillaries, lymphatic capillaries, that converge into collecting vessels that will enter a node, and then they'll exit. We have apher and ether collecting vessels, and then those will merge to trunks, and the trunks will merge into two ducts that you have. So that's a very simple process. Again, your lymphatic capillaries have little one-way valves, so fluid can go in, but it can't go out. Kind of neat. You also have some unique lymphatic structures called lacteals, all right? And again, here's another weird part of the lymphatic system that doesn't have to do with either of the other ones. The lacteals are all about bringing in fat from the digestive system. So we'll talk more about the lacteals when we get to the digestive system. So those are unique. The lacteal are blood vessels, or excuse me, lymph vessels that are found in, this is part of my small intestine. We haven't covered yet. Right? And again, so when you absorb and digest fats, the fats will go not directly into the bloodstream like your amino acids and glucose will. The fat will go into the lymphatic system and ultimately get to the bloodstream later. Again, don't worry about too much about lacteals here. We'll worry about that in the digestive system. So these vessels, collecting vessels, are again have the same type of structure as a blood vessel, between tunics, layers. They have a lot more valves. Again, we want the lymph to ultimately get to your subclavian veins and introduce back into the bloodstream. Again, lymph is propelled by contracting skeletal muscles. The lymph nodes, again, structures, nodal structures that typically are clustered in groups in strategic areas. So you have cervical nodes, axillary nodes, and the inguinal nodes. So literally on a lab practical, I could say, what is this? And you're going to say, inguinal lymph nodes. Everybody see that? There's not a whole lot to the lymph system as far as identification for anatomy. The only other unique structure is this cisterna cheli. Everybody say cisterna cheli. That's just a swelling there. So again, your lymph node has a fibrous capsule that maintains its structure. Again, there's that word trabeculae. When's the last time you heard that? You've heard it 2 times in your life. And the ventricles, okay, the pattern of ridges in there. Where's the other time you heard trabeculae? The bones. So again, the trabeculae is just a word for just having, you know, an intricate network-like structure. So we have the trabeculae, and so this is the fibers that make up the trabeculate, and then you'll have actual cells just hanging out there, lymphocytes. Okay, lymphocytes. We have afferent vessels going in and efferent going out. Any questions? The lymph trunks. We have 5 major trunks that again are going to be receiving blood from the efferent vessels: lumbar, intestinal, bronchomediastinal, subclavian, and jugular. Those are your 5 trunks. Those will ultimately merge to form our ducts. You have the thoracic duct that drains 3/4 of it, and the right lymphatic duct for 1/4. They basically, their entrances are right there between the subclavian veins and the jugulars. Everybody got that? And I'm just going to be honest with you, since there's not much, I'm going to ask you one of these two, and your cysternoculi, and this thoracic duct. 1 or 2 of those will be on the left. I'll do that right now. Not much else to do. We have lymph organs. The spleen is considered a lymph organ. Your tonsils and the thymus are organs. You also have lymph tissues. Again, the thymus is very active when you're young. When you're developing your immune system, that'll make more sense when we start talking about an acquired immune system. Once you're older, getting past the age of 40, you have a pretty well-established immune system against most of your prevalent types of infections. The thymus doesn't have as much work, and so this will typically atrophy and they'll shrink up in an adult. That's all you need to know. Again, lymph nodes are basically functioning to take that fluid and surveying it for any kinds of infections. Lots of lymphocytes, which are your immune cells, and they're just checking out to see if that fluid has anything like a bacterium, virus, virally infected cells of yours, or cancer cells. So that's where the war starts if you have an infection. How many have ever had painful little swellings under their arms or when they're going? Anybody? Yeah, most people have. Right? That's a war going on. 99% of the time you win it, so it's no big deal. It's not something you need to run to the doctor for immediately. If it stays there for a month or 2, yeah, you need to go in there. But when you get those swellings, that means those lymph nodes are doing battle with some sort of bacteria.
Do they swell whenever you have allergic reaction?
They could. They could. Again, we'll talk more about what the allergic reaction is on Monday. That's part of your immune system. Spleen is the largest lymph organ. Okay. 2 functions are, again, to remove those old dying red blood cells. As well as any, again, bloodborne antigens. Again, remember, antigen is something that your immune system considers to be foreign and will attack. It's also a storage place for platelets. The white pulp, let me have a picture here in a second, is mostly lymphoid tissue, i.e. Your white blood cells. The remembers the type of connective tissue you find in the spleen. Very good, Stephen. Reticular. And the red pulp is where there's a lot of red blood cells. Okay. Circulate through there, and the old ones will die. Your tonsils, again, you have 4 groups of tonsils. The adenoids, probably any of you know, are basically your pharyngeal tonsils. Palatine, lingual are basically given that name for where they're found. Very simple. Back in the olden days, in the 50s and 60s and 70s, if you got persistent throat infections, they immediately did what? Cut them out. Cut them out. They don't do that anymore. But most people my age had their tonsils removed when they were young. Just to avoid. The threat was that the infection got bad enough, the swelling could cut off your breathing and whatnot. Not necessary. You'll have to know, and I'm just going to be nice to you. You need to know pharyngeal, palatine, and lingual. And again, it's going to be easy because they get the names for where they are found. So the lingual is referred to. What are we referring to here? The tongue. And palatine is referring to the palate. Okay, in your mouth. And the pharyngeal, again, it's your pharynx area. Behind the nasal cavity. So yeah. This is more for lab practice. Yeah, this is strictly for lab practice. I'm not going to put any of this on the lecture. There's nothing. You got something that has the acronym MALT, mucosa-associated lymphoid tissue. Where do I find my mucosa? Where's your mucosa? That's it. Come on, guys, that's a simple thing from Anatomy 1. Say it, where? In the intestine. It's just the lining of any of your hollow organs. Mucosa. Yes, your intestines and other places. So within your intestines, you're going to have clusters of this MALT. And again, it's going to contain a bunch of lymphocytes. And they're strategically located because obviously your digestive system is where you are going to introduce foreign things, i.e. you're eating and drinking, into your body. And so those are there just in case you swallowed something and had a bad thing in it. Pathogenic microbe. Don't worry about this being suspicious. Why do I hate this? Somebody's name. Okay. And again, these are just lymph nodules that are found, again, the distal part of the small intestine. What is the distal part of the small intestine? Oh, that's right. You don't know that yet. I'm sorry. You haven't taught. All right. So that's why we call it. You'll have to know the 3 such segments of the small intestine later. Your appendix is considered offshoot of your lymph system. What's its purpose? Appendix, what's its purpose?
I don't think it really has one.
It doesn't have one. Its only purpose is to rupture and kill you.
Which mine did, not kill me.
Oh. I'm sorry. So you had a rupture? Yeah, that is a very dangerous thing. That's scary to me. Basically, what you're going to learn when we get to the digestive system, when you get down to the large intestine, to include your appendix, you have billions and billions and billions of bacteria there. Now, as long as they stay in the digestive system, they can't hurt you, right? Because the linings of your small intestine and large intestine are protected. However, if you rupture your appendix, you release all those billions of bacteria, and then you're going to. Was it really painful? Is that how you knew? Yeah. Usually, if you get a really horrible pain right there, Like, oh no, right? But
It
again,
was like to my belly button because it like refers to the birth,
Yeah.
but I was just really sick, like
Yeah.
growing up.
yeah, because like I said, now you have all these billions of bacteria floating around attacking all your organs.
Wait, so what's the distal part of the small intestine?
The ileum. Duodenum, jejunum, and ileum. But you don't need to know that yet. Okay. All right. What was the original purpose of the appendix? And again, this is what we assume. It's sort of like cows. You all know that cows have several stomachs, right? Why do they have several stomachs? There's no other cow anatomy, physiology. Yeah, more efficient in digesting. They eat grass. Who can impress me and tell me what's the primary molecule that make up grass? Cellulose, okay? And cows, just like us, do not have the enzymes to break cellulose down. Cellulose is just a polysaccharide of glucose. It is pure pure glucose. You just don't have the enzymes to break that glucose down. You have the enzymes for starch, but not cellulose. So if you eat grass, you're not going to break it down. So what do we call that? Fiber. Very good. That's fiber. Right? Fiber means cellulose. Right? So, you know, because it was funny, I was watching some stupid survival thing. Oh, we lived on grass for 2 weeks. I go, no, you didn't. No, you did not. You may have ate grass, but you would get no nutrients from that. Cows don't either. What do they have? They have bacteria that break the cellulose down for them. So they have a little mutual thing going on. You can't break down or can't eat all the glucose. Right? So most animals that are herbivores have structures, sacs, where there's a lot of bacteria that can break down grass plants. Okay, so again, keeping it simple for the lymphatic system. Keeping it very simple. All right. Know the groups, the inguinal, axillary, and cervical. Know the thoracic duct and the right lymphatic duct. So you're good with that. And we're controversially exposed to the thymus on the last lab, and some of you were not happy with that, right? See, not even paying attention to. Okay.
Oh, I'm paying attention.
Yeah, what are you talking about?
It's just not my fault. It's y'all's keys' fault.
It's kind of funny. I looked at our key and I'm like, what happened there? And then I went online and I pulled up that plaque, and yeah, so no one got anything off of that. Half the plaques called it the thymus, half called it the thyroid. So that's all messed up. They really screwed that up big time. It was supposed to be the thymus, but a lot of them mislabeled it as a thyroid.
The actual plaque or online?
The actual plaque online. They had a picture of the plaque online, and they had labeled it, and whoever labeled it mislabeled it half the time. It's kind of ridiculous.
Unsettling.
Yes, it is. Okay. All right. This is one of my favorite subjects. We'll just introduce it and call it a day. Why do I like the immune system so much? Say it. It's all about war, battles, carnage, destruction, death. A lot of military words can be used to describe your immune system. In fact, the very first one, I thought that was a common knowledge word, but then I remembered, oh, I spent 25 years in the Air Force. Well, most people haven't used that word. Here's what reconnaissance means. Stephen's known everything. Anybody else? What does it mean, Steve?
It's like gathering intelligence.
Yeah, reconnaissance is basically doing a word that you would be more familiar with is surveillance. Checking, watching things, looking for the bad guys. Right? So your immune system is all about looking for invaders. Recognizing whether it's friend or foe. Is it part of me or is it a foreign invaded? And then respond. If it's foreign, I need to be able to respond to it, suppress it, or destroy it. Okay, suppress it or destroy it. Okay. A lot of communication. You know, lots of aspects or facets to your immune system that they all work together to engage in the big war. There's a terminology I'm going to use here because I'll use it interchangeably. They do mean different things, but not for us really. So I've told you we have this word antigen, and that just means something your immune system responds to. It could be something as simple as a protein, something more complex like a virus, or something really complex like a bacterium, or a cancer cell. All those would be considered antigens. Okay? If the antigen is disease-causing, okay, it is called a pathogen. Okay? So a pathogen is an antigen that causes disease. Everybody got that? There are antigens that aren't disease-causing. They aren't disease-causing. They're foreign to you. Your immune system is going to respond, but the antigen isn't going to hurt you. Isn't going to hurt you. All right? It's inert. Right? A type of antigen that doesn't cause disease, you know as an allergen. Okay? An allergen. So, again, allergen is something that initiates an allergic reaction. It's an antigen. So I will be using antigen and pathogen interchangeably, but I want you to know the difference. So we look at our immune system and two major types of defense. The innate immunity, what you're born with, and the acquired immunity, what you acquire, develop throughout your life. Okay. So your innate is present at birth, and this would include things like those white blood cells, the neutrophils, the basophils, the eosinophils, monocytes. You have those when you're born. Okay. What you don't have developed at that time are the lymphocytes. Okay. So the present at birth, they will respond to anything that's foreign to you. There's no lag time because they're there already, especially the neutrophils. Remember, 67% of your white blood cells are neutrophils. When you get older, the innate will work with the acquired. The acquired is, again, the process of you being exposed to an antigen or pathogen, and your body responds by making an army of lymphocytes to fight it. So some key things here. It's very specific. It's very specific. If you get an infection, let's just say a simple cold virus, rhinovirus, it's going to take some time, so you're going to suffer for however long, 2 or 3 days, but while you're sitting there blowing your nose and feeling miserable, your immune system is creating a large army of lymphocytes that are specifically targeting that virus, the cold. Everybody got that? If that army won't work for any other virus, just that. Everybody got that? Once you get over your cold, now you have antibodies floating around that will protect you from that particular rhinovirus. You will never get sick from that one. The next cold you get is a completely different virus. So over your lifetime, you read some of those old English novels, and like, Alfred was a sickly child. In reality, like, he may have been a sickly child, but he's developing one heck of a immune system when he gets older. Right? So what I was going to say is, if you had 30 or 40 colds in your life, you have 30 or 40 different armies of lymphocytes, so that eventually we just don't get sick like we did when we were young. Not normally. Okay. All right. So, and this is to just be my little 2 cents. We're heading in a dangerous world. We're trying to sterilize our kids, you know. Make sure they're germ-free, put them in a bubble. All these hand users and sanitizers. Why is that bad? Yeah. Your immune system is use it or lose it. You need to expose little baby to all the things. If he's got a freaking frog in his mouth, you know, you can take it out eventually, but that doesn't mean you run to the emergency room and start drowning them with Listerine. Okay? Babies need to get exposed to all the stuff that's on the floor. That's not the same thing as what you guys are going to do in a hospital. That's different. Why do you want to be very sterile and aseptic? Not to help you, so you don't pass things from one patient to the other. Right? It's a totally different thing than what I'm preaching here. Yes?
So I think I saw, like, okay, so this is like a movie thing, so I don't know if it's real, but like, I think I saw in like some like disease movie where like there was like some outbreak of like disease all over the world that was killing everybody, but there was like a little girl who was immune to it already. But I mean, how is that possible?
Oh yeah, that's possible. That's very possible. We've had plagues throughout the history of man that didn't kill everybody. My favorite one to study is what was called the bubonic plague or the Black Plague that ravaged all the way from North Africa all the way up through Europe up to England. It killed 2/3 of the population from Africa to England. 2/3. They estimate around 9 million people died. Again, this was in the like 1300s, 1400s. But it didn't kill everybody. And there were those people, the chosen ones, that are standing there, and everybody around them is dropping dead, but not them. Okay? That is because they were lucky that they had the genes, the genetics, to create an antibody for that others did not. So there's one of those things about diversity. We don't all want to be clones, because if we were exactly genetically identical, if you had a plague, you wiped out the entire species. So that is a very real thing. Okay. Same thing with the Spanish flu. That killed tens of millions of people, but not everybody. Not everybody. And we'll talk more about that. So let's we'll stop right here with just this last slide. This is just a kind of a summary. So you have your innate, what you're born with, your neutrophils and monocytes. Then there's acquired. Again, you have to be exposed, and when you're exposed, you create antibodies and lymphocytes. Right? We have the passive immunity, where you're going to actually transfer these antibodies to an individual. All right? Mommy does that when she breastfeeds Junior. The milk has antibodies in it. Okay? Same thing with the placenta. And I thought I mentioned this to somebody. That was my EMP one class. You don't know this. Mommy and baby do not share blood. Right? They don't share blood. That placenta is a filter. Plasma can go through, antibodies can go through, but no red blood cells and things. So mom gives it to Junior, and we have the other where you can take antibodies and you made the antibodies from some other process and you gave. That's rare. That's what we would call a serum. The ones that are most common here would be for snake bites. Okay, the venom in a snake are antibodies, and are antigens, and so you can give them the serum that will bind up the venom so it doesn't destroy your tissues. But primarily we do the active immunity, naturally acquired, i.e. you get sick and you recover and now you're good. The other way, which is that time of year, folks, is what we call induced, i.e. vaccines. You are given the antigen or the pathogen in a very, very weakened form, sometimes dead, or maybe just a fragment of the pathogen, but a sufficient amount of that structure of that virus that your immune system responds, produces lymphocytes and antibodies. But the pathogen was so weak or dead that you didn't get sick from it. Does that make sense? And again, like I said, it's flu season, flu shot. Do we know exactly what virus is going to spread? No. They take their best educated guess. CDC, our CDC works with other parts of the world trying to figure out, and they'll pick maybe the top 2 or 3, and so the vaccine you get will may have parts and pieces of the 3 most prominent viruses.